Greetings, class. I've had a couple of emails about problems from Chapter 5, Section 4, about using StatCrunch to find probabilities with sampling distributions. So I found an example from the study guide 5.4.15, or out of the study plan. And it says the population mean and standard deviation are given below. Find the required probability and determine whether the given sample mean would be considered unusual. So it says we took a sample of 70. So from a population that we already know the mean and standard deviation for, we took a sample size 70. We want to find the probability of a sample mean being less than 19.5 if the population mean is 20 and the population standard deviation is 1.18. In order to use StatCrunch, we actually have to know the standard deviation for the sampling means. And in order to do that, we take the standard deviation for the population and divide it by the square root of our sample size, n. So if I go to StatCrunch and go to Data and compute an expression, the expression I build takes my standard deviation, my 1.18, that's the standard deviation for the population, and I divide that by the square root. So I'm going to scroll down. Now you can type it or you can scroll down and find square root, SQRT, right there, SQRT. Or you can actually just type it SQRT parentheses, and n is 70, so I take the square root of the sample size. And I'm going to click OK, and I'm going to click Compute again. And so you now have, I'm going to close the box. It's hidden, but it's not deleted. I'm going to go ahead and enlarge the little so you can see. And this is what we refer to as the standard error of the, and I'm going to go down one more, mean, or sigma sub x bar. In your book it has the symbolism sigma sub x bar. The x bar is a subscript on the sigma, but what it is, it's the standard deviation of the sampling mean. Now that I know this, 0.1410, I use that as the new standard deviation with which to find this probability. Now, if the population mean is 20, then the mean of the sampling distributions is also 20. They'll have the same value. So I go to StatCrunch, Stat, Calculator, and it's still normal. This is still a normal distribution because we, by the central limit theorem, if you have a sample size that's greater than 30, the sampling distributions will be normal, will be a normal distribution. So my mean for the sampling distribution is the same as my mean for the population, 20, and my standard deviation, I don't want to have to type that in, so I'm just going to go back up here and I'm going to do a Control-C, go to my standard deviation, Control-V, and now I've got the standard deviation that I calculated, or the standard error of the mean. And I want to know the probability of a sample mean being less than 19.5. So I'm going to do 19.5, and then I'm going to compute. And so this probability here, I'm going to do a Control-C, and I'm going to come over to my stat lab and do a Control-V, but I only want to keep 4 of those decimal places. So if I look to the right, I have 0, 0, 0, 1, and then a 9 is going to make that one a 2, and then I'm going to delete all the places after that. So hopefully our answer is 0.0002. That is correct. Now I have to decide if it's unusual. Remember, if the probability is less than 0.05, which this one is, it would be unusual. So the sample mean would be considered unusual because it has a probability that is less than 5%, or as a decimal, 0.05. That is definitely less than 0.05. There are several other problems where you don't always use less than. Sometimes you use greater than. I'm going to pause for just a minute and see if I can find one that does a between. I found another problem from the study plan, which looks like it might have been someone's homework assignment, but let's go ahead and look at it anyway. It says, find the probability and interpret the results. If convenient, use technology to find the probability. During a certain week, the mean price of gasoline was $2.0702 per gallon. A random sample of 36 gas stations is drawn from this population. What's the probability that the mean price for the sample was between 2.689 and 2.719 that week, assuming that the population standard deviation is 0.047? Now, I've already done a problem over here in StatCrunch for the first question, so I'm going to close this, and I can actually work another problem here. I think it'd be pretty easy for me to see if you do another data, compute, expression, and build. We have to take the standard deviation of the population, 0.047, and divide that by the square root, and I'm going to type SQRT this time, and the square root of the standard deviation, square root of n, n is a random sample of 36, so n is 36. So we take my population standard deviation and divide it by the square root of my sample size, n. So I'm going to click OK, I'm going to click compute, and now I have another standard error of the mean. And if you want to identify the problem, like this is question, it's actually question 16. So you can tell me which problem it's from if you want to go that way so that you don't have to keep uploading several different StatCrunch sessions. Then using this, I'm just going to go ahead and copy it, Control-C. Well, I don't know that copied. I'll check and see. Go to Stat, Calculator, Normal, and our mean we want to use as the mean from the population, 2.702. $2.702 of a dollar for a gallon, and the standard deviation, let's see if that copy, I'm going to try Control-V and see if that's what it was, 0.00783, yes, 0.00783 with lots of threes. Okay, I'll move this back up where we can see the bottom. This time, because I want between two values, I have to click the between on the calculator, and my lower price was 2.689. My upper price was 2.719. And I click compute, and here is the probability. I'm going to do Control-C. I'm going to go over to my Stat Lab, Control-V, and I only want 4 decimal places, so I'm going to back that up. And after the 4th decimal place is a 0, so that 5 is going to stay the way it is. I'm going to check my answer. It says that is correct, and I have to interpret the results. So it says about 6% of samples will have a mean price between, well, that's not 6%. If you change that decimal to a percent, that would be almost, well, it would be 93.65% or 94%. So I know it's either C or D. About 94% of the population of 36 gas stations that week will have a mean price between $2.689 and $2.719. Or about 94% of samples of 36 gas stations would have the mean price between those two values. And so actually it's the samples of 36 gas stations. The population wasn't 36. We took samples of size 36. So if I did this sampling over and over and over, I would expect 94% of the time that I would get a mean price between $2.689 and $2.719. Let's check that and see if we're correct. And we did. So I'm going to complete this recording, and I hope that you find it helpful for Chapter 5, Section 4.